proof of work to create those big prime numbers that give assurance that this is a legitimate transaction. That's what incentivizes the Bitcoin network. Here, the idea is with Filecoin that people would be incentivized to put more and more storage online. So the idea essentially becomes you come up with a decentralized cloud, if that makes sense, rather than one big mega cloud behind, one corporate firewall. The idea is that you have lots of clouds that are connected together. This is just a graphic picture of, this hash number. And that's a unique number out there in the world of data. It's maybe hard to believe, but it is unique, and it's what retrieves that document uniquely. Now, again, the document as it sits here isn't encrypted, so that's sort of a separate process that you got to go through. I've included, won't go through in detail, but I've included a couple of kind of key academic journal-type articles that have been published, and people can refer to them if they wish. This is the Licklider note that I was referring to, so it dates back to 1963, and it refers to members and affiliates of the Intergalactic Computer Network. So it was, in the early days, that's the way Licklider described it. This is, again, about Live P2P. No surprise here, I guess it goes without saying, I don't think I've said it yet. This is all open source. A lot of it is MIT licensed. I don't know if it's all MIT licensed, but the things I've looked at are. So there's a real sense of openness to this. I've spent some time, not a lot of time, but all the code is there. If you're uncertain as to what, a lot of it is in Go, and so which is kind of another attraction to me. Big shift though away from this client-server model and into a different way of doing things. It builds on top of the existing protocols that exist today. One of the things they've done with this is it's made it really elegant. They've put a lot of thought into how to get IPFS adopted and moved out into the real world in an effective way by leveraging what's already there. So they're not saying we have a better way and we're going to replace everything that's out there today. Their stuff rides on top of accessible space. And so they have changed, that they've proposed this naming scheme that kind of drops the colon and the / and they've moved to more of just I think that there's a name that they've got for it, a clever name they've got for it, but it's moved more to a Linux version of file naming actually. We talked a little bit about where IPFS is stored. We can kind of look at it here. It's a very clean installation. As Kurt mentioned, it was easy for him to do. It kind of hides all this your configuration stuff in this hidden directory. But you can go right in. When you create when you install it, it gives basically your device a unique hash number, or peer ID, or an ID. And so that's essentially how your device is recognized to other devices that are out there. And that kind of works its way into the hashing of where the data is located as well. This actually is sort of what the hierarchy of that directory looks like. I haven't gone through everything, but but it shows the blocks. And it shows kind of I have not traced all the blocks that are associated with the PDF file, but someday I hope to be able to do so. This Licklider again. Kurt, I don't know if you've ever heard of this. So this kind of goes back a ways. I grabbed this off of the CSAIL website, but this was one of the early seminal works on sort of how to handle these distributed hash tables. And and one of the clever things that Juan Benet and the other developers of IPFS have done is, and it probably must tie back to the roots of this, kind of from the Stanford classroom is my impression. They've really looked at what the cutting-edge, state-of-the-art software architectures are that are out there, and they've said, how can we kind of build on the shoulders of these giants and leverage them? It's really, quite elegant. There's a lot of novel stuff in what they've done, for sure, but there's a lot of existing architectural software that they have sort of moved to a higher level. This idea of greedy routing, I don't know if you ever heard of what greedy routing is, but the idea of what you're looking to do is you're looking to optimize the solution at a local level rather than trying to optimize the solution internet-wide. And this is where it gets a little bit, I think, into both the higher science and the philosophy of the stuff, but the belief being that if you optimize it through greedy routing at the local level in what's in your best interests, as it turns out, that generally is optimal for the larger scale deployment as well. So there's a lot of cool stuff that goes in. They do have interconnects into like AWS, as you know, because you do have to store stuff in you know, somewhere, and you know, whether it's the AWS, you know, cold ice storage or wherever, you need to have live spinning disks or, you know, thumb drives or something out there that are maintained. Again, with the idea with Filecoin is that they'll create a market of their own. This is just included to show you, well, first of all, some of these papers, names that you may or may not have heard of, but there's a lot of really great background that's available for this. You know, the question about encryption, and so as I stepped through this over the past couple of months, these questions came up. Okay, it's great to be able to access this stuff from anywhere, you know, it's great to be able to kind of sneak through the gnats without having any problems. It's wonderful in some sense to be able to go peer-to-peer without having to go through, you know, a chokehold in the middle. But what about things like encryption? And you know, it's not done for you, it's not taken care of for you, and there's nobody behind the curtain who's going to assure that your data will be safeguarded. So they've left this kind of as an exercise up to the user, and my sense is what this is going to do is it's really going to drive encryption into the mainstream as a default, you know, from the point of data collection as we proceed into the future. This is I don't know if you ever heard of this end-to-end argument in system design. Some folks from MIT and both, you know, faculty and recent PhD, I think, at the time. The idea being that you know, there was a long argument back in the day when this was, you know, sort of developed. Where do you place functionality, like for instance encryption, in throughout the network? And different people, I mean, in some sense, Akamai, maybe this isn't a good example, but you know, they put these different juncture points everywhere to get closer to the consumer of the data to essentially expedite, accelerate the dissemination of information to the users. Well, that's kind of something that's in the middle of the network, right? Now, you could argue, you know, what should go into the middle of the network versus what should go at the end of the network, at the endpoints, basically the departure point and the arrival point. So the reason I bring this up here is because it definitely seems with IPFS that encryption is something that happens at the ends. It's not, you know, it's not taking place in the middle of the network. For me, a big part of IPFS that was kind of a relief was this idea that you actually can do this NAT traversal, which is, you know, if you want to get to the devices in your, you know, behind the NAT, behind your modem, behind your router, it's kind of difficult and complicated to do. And if you want to do this for IoT type applications, which is something I've been interested in, this is looks like a real clear-cut solution. They have a bunch of this is awesome IPFS. The point I use with trying to make right here is that they've done a great job documenting, disseminating information about applications and developments with IPFS. The point being that if you're interested in this stuff, there's nothing to inhibit you from just diving right in. They do a good job of breaking out the architectural components. This is, I don't know if people use GPG. I hadn't really used it much before this, but it's, you know, it's kind of a snap to do, particularly on Linux machines. That you know, essentially you're just encrypting it with a public key and a private key, and then you know, when you ship the stuff over to the other person, you do it with their public key, and then as a recipient. But the workflow in all of this is pretty ad hoc, you know, and so I'd be at least as likely to lose the keys as, you know, as anything, and then there goes your data. So it raises a whole host of issues on how. This is actually where I kind of started putting together the slides, and I'll breeze through this, but you know, here, this is the example.com. This is the location-based traditional way of accessing things. This kind of shows that green circle in the middle is, you know, the point where these subnets come together, kind of thing. I don't know if subnet's the right terminology, but you know, the question is, how do you get stuff going back and forth between these, particularly if you've got, you know, NAT traversal and all this other kind of stuff. Here, I was just essentially trying to trace the packets as they move through the network. I haven't found, and this is sort of the traditional existing setup, I haven't found anything that's as clear-cut on how it works with IPFS, which eventually I'd like to get to. This actually is a pretty cool, well, two things. One, Benet, this is it was his TED Talk, and hey, you should read this great book. You know, go to New York Public Library, Section 9, Bookcase 3, top shelf, first from left. The idea being that you're not interested in, you know, going to the New York Public Library to get the book. You just want to get the book, you know. And so the idea is moving from location-based, like on that shelf in the library, to content-based, which is that book. But the reason actually that my first reaction to this, one of the neat applications that somebody came up with, which is, you know, appears to be a working application with IPFS. You could take a document, the PDF, and you could process it in a way that I can show you in a minute to create the hash. And then the question is, how can you let people know sort of what the hash is so that they can go out and find the PDF? There are a lot of different ways you could do it. You could, you know, you could just email it to folks, or you could read it off to 160 bits and they get it. But a very clever application is they essentially put like a tag on a world map, and they say, you know, okay, you can find the book in Barcelona, Spain. And so you go to this application map, you click on Barcelona, Spain, and it pops up your 160-bit. So it's kind of a different way of sharing information, and it's location-based, but not really. Okay. This is what they've moved to now. This idea that it's not about where the stuff is stored, but it really is, it's this content-based IPFS, and then the hash, and then there are different ways of moving through the directories. Where the current state of the system today is, from a development perspective, the places where I started to get, you know, kind of come up with dead ends. But when this is IPFS, this is a hard-coded thing. If you change any data in this file, it would change the hash that is created from that file. And so therefore, the hash is uniquely tied to a static collection of bits. Whereas with the web, if you know, you've got a sort of a help file, right? You change the help file, people still go to the website and they click on the help file, it just brings up the revised document. So here you have a bit of a disconnect, which is when you change the document, you change the hash that's created from that content. And so the question becomes, how do you essentially update and maintain the documents as you proceed?
You kill them.
Yeah, sure, that's great. Yeah. You with me on that? That's kind of a subtle thing. Now what they've done is they have IPNS, which is the Interplanetary Naming System, and essentially it's kind of a DNS-like mechanism for targeting at least directories, where it's a stable reference that then brings you into the lower. But I've had kind of mixed success working with it.
Is that like a unidirectional or bidirectional?
In what sense? So it's.
I'm thinking in terms of the old Xanadu project, which predated the World Wide Web.
Yeah. And
one of their big main goals was to prevent a system that had unidirectional links, like the World Wide Web eventually did.
I mean, I guess it's bidirectional. All the stuff is bidirectional in the sense that you kind of know where it came from, and you can get back to it.
So if you had a particular document, there's a way you can you can easily tell that oh, there's a newer version and here's a link to it, and there are older versions. Here's a link to it.
So that's actually a great question, because that's another area where I've kind of gotten to a bit of a sort of a stopping point. For instance, I can show you. I've got a bunch of files that are on this machine that have been chunked and hashed and distributed and stuff like that. But darn if I can't I can't find what the names of the files are. There's a way that when you hash these things, you can essentially wrap them with information about the name and the directory and other kind of systems. But that is really still developing. Okay, there are great tools for showing what hashes exist on each of these machines. There are great tools for showing which machines you're connected to, and I believe even which hashes exist on these other peered machines. But actually just like getting from Joe's PDF to this 160-bit back to Joe's PDF, just like to do a directory listing, it's not quite there yet, right? But the other thing that I've seen, and another system is Minio, which is essentially an S3 compatible document management, blob management system, right? And they've taken a similar approach to IPFS in this respect. They've taken common utility functionality, ls for listing or get or put, and essentially what they're doing, commands that you would use locally on your Linux box, they now work, sort of out there on the distributed or decentralized web, or out there on Minio. So what you're finding is the keystrokes actually are remaining the same, but the functional content is kind of moving, migrating, whether it's to the cloud or to this decentralized network. But you can, essentially the distributed hash tables, you can kind of climb up them and then you can walk back down them. That's more or less the way I believe it works, right? So in that sense, there's there isn't anonymity in terms of you would be able to figure out the cluster of activity and documents that originated from a certain source, and somebody could walk. There's probably somebody who's working on a Google-like search mechanism for the decentralized web, today. I don't know who that is, but again, this is just a bunch of we'll jump over that. And
this is always possible that everyone's assuming someone else is working on it and no one actually.
Yeah, no, people. There's no doubt people are busy. This is sort of we've talked through this, so I won't go through it. But the idea of a centralized web or centralized network. There's this choke point right in the middle, right? That goes down, we're toast. And it happened with the DIN, some time ago when they were sort of under attack. Then there's this is centralized. This is decentralized, which there's still centralization in it. I mean, it's varying degrees, but there's still kind of central connecting points. Distributed, which is really what the more the model is for this. Any point can get to any point through basically any other point is the way it goes. Does that somewhat make sense? Mm-hmm. Brewster Kahle, I mentioned him from the Internet Archive, and he's been, I think, both an encouraging sponsor. I referred to this earlier. This was the story, September 2015. Where have all the Geocities gone? This was one of the motivating events that actually is Juan Benet. There are a bunch of very good videos out there. It's the portfolio of protocols is just, pretty much everybody in this room has lived through them, so it's kind of second nature at this point in time. But this guy, and the team of people, they've really woven these together into kind of a very new way of thinking. It's just a different model. There's actually, this is just from a practical standpoint. This is the Gangman video that was like mega million people have seen it and stuff like that. And so sort of the thought is that the classic classroom where everybody in the classroom is watching the same video. Well, they're all going back up to the same central location that is streaming the stuff all the way back down to the, you know, to the duplicate groups of people who are sitting right next to each other, and there'd be much less traffic if it could be localized, it could be shared more locally. That's, you know, more or less that's what this example is here. The thought that, you know, people are working on, for instance, a shared document in a classroom, but they're all going, you know, kind of thousands of miles away, when in fact they could be working basically with the images that are right next to them. And that's much the model of Git that Git you know, sort of advocated. We talked about this before, you know, the addressing model. Git's a big deal. It certainly is a role model for this. This is just another look at this concept of Merkle trees. What they seem to do, and it's interesting to watch, that the beauty of this is that it's still young enough in the history and the evolution of IPFS that if you wanted to, you could get into it today and you could really track it through. You know, the question is, since it's not proven yet, not rolled out and deployed, there's some argument that centralized organizations, corporations, will have no interest in this, because the last thing they want, arguably, is their business model is not conducive to having this data flowing around loose on all these different machines. It's, you know, there's lacking controls, and what are the access controls, and you know, and the whole bit. So there's, you know, you might argue that there'll be serious resistance, at least in the corporation, to adoption of these technologies, as perhaps there was with, you know, personal computers and smartphones, and, you know, and look at the world today. But what is interesting about IPFS, you know, it started, I think, it appears to be literally pure academia, you know, academically driven, looking at the history of time, what the architectures were and the developments that, but what it seems to be happening now is, having built on that really strong foundation, there's more and more kind of cultivation and customization of you know, and they're starting to roll in their own secret sauce, I guess. But since it's all open source, it's, you know, public secret sauce.
Yeah, I think our resistance isn't really that big a deal anyway. And we went through exactly the same thing when we were rolling out the internet, and businesses were using things like CompuServe and all these other things.
Right.
And that same resistance existed to using the internet where it would be available to everyone.
Right.
But inevitably, the other business models failed if they didn't use internet. So they pretty much had to go along with it.
Yeah, actually, that's a good point. So you know, it's do you want to be a, you know, a brave leader or just a fast follower or something like that? Mm-hmm. But potentially, if companies you know, move to this model, and they find that, as with Git, for instance, it really facilitated a new way of doing business. It certainly has with Linux development, I suspect. If corporations find that this gives them new capabilities, and because it doesn't break the compatibility of the stuff that they're already using, it's an easy pickup, you know, in that sense. You're right. I mean, that certainly is an optimistic, you know, outlook. So this is kind of the Web 1, 2, and 3. You know, a little bit of the idea here is that with IPFS and the distributed web, you can do a lot more in terms of publicly verifiable stuff. We talked about the idea of a search across. We talked about the ability to essentially identify the sources of all of these things and trace them right back to the sources and uses. That, you know, there's some benefit to that. You know, disintermediation, we've kind of talked about that. Here are some of the, you know, the motivating factors. You know, location versus content, bandwidth, latency. Latency's delay, the idea that you're going to wait for the stuff to come back from, you know, the left coast when the document was sitting in the seat right next to you, that kind of thing. You know, security, authentication, and encryption at rest. That's but I'm actually confident that's a doable thing, and I do think that will really force people just to use this more widely. The idea of permanence is the Geocities thing. The idea that you want to have access into Merkle DAG. It keeps coming up. Okay, so here are whoops. It's touchscreen. I forgot. Here are some of the commands, and I can kind of show you how. Basically, in brief, you install it. You run, for now, you run daemon. The daemon runs in the background, and it's just looking for these commands. You know, And so someday I'll get confident soon, and just it'll become part of the startup, and it will always be there. These are just the common ones that I ran through, and repository, you can get stats, the swarm addresses, these are all the devices that are connected out there to you. You get version information, the bootstrap list, which I haven't messed around with too much yet. There is evidence to suggest that you could essentially wire up, hand code your own private network. So the idea being that you could create maybe an enterprise distributed network that is, kind of on the inside of your firewall, but it wouldn't be circulating and sharing and chunking information with the public side of it. So that actually, there's evidence that you could do that. It doesn't, and that might be useful if you've got your own little, multi-site setup. All you want to do is share this stuff within your own site, just to specify essentially the routing and stuff like that. Should work, it should be doable. It would be great if in fact that ultimately is supported. But most of these other things are, I'll just jump down here, the concept of pinning. So the default mechanism is that when you share stuff, it's when you move it around this distributed net, it's kind of got a timer built into it that it disappears after a certain period of time. So this periodic garbage collection, so they've used concepts, the garbage collection like in memory management, right, that are just now working at the node level of things. So periodically, and I don't know if it's every 4 days or maybe it's configurable, but after some period of time, if it hasn't been accessed or hasn't been used, it'll get wiped out, right? So what you can do to maintain it and keep it there, you can just pin it the same way you can pin a post on any one of your favorite social media sites. There is this concept at the bottom here, pub/sub, the idea that you can publish and subscribe, and this is where somewhat the IoT stuff comes in. To run it, and I have run it a little bit, you kind of start up the daemon with the experimental sort of attribute on it. And then what it does is that anytime that content changes, it sort of sends a message back to the other party that says, hey, it's changed. So in some sense, it's addressing that the dynamic aspects of this, which currently much of what IPFS is, it's kind of geared towards this permanent static.
Is it still tracking older versions? Because often you want to refer back to those older versions.
The concept of versioning is like definitely there, but there's nothing inherent in any of the tools that are available to sort of assure that. So for instance, what you do now, the way when you if you essentially you put stuff out there, right? And the process of putting it out there creates new hash. And so let's say you change the document, you run this command again, you put the stuff out there, creates a new hash, and that new hash is now available, right? So the old hash hasn't gone away, the old data hasn't gone away, and essentially it would be great if somebody could come up with a versioning mechanism that would say, hey, this is actually that'd be probably a great product or service, right? This is a variation, and I guess that's probably what Git does.
Git's all hash based.
Yeah.
So what you do is you're committing a file,
yeah,
or you're committing a release or whatever, and what you get back is a hash, and it's called a commit.
Yeah.
And you have your history, so you can always go back to older versions.
Yeah. So that
I guess my big concern is if everyone's rolling their own version system, that's far less useful than having just a general version system. In fact, even calling it a version system is it's probably not that good. The concept's really more general than that.
Yeah, yeah. So one of the things just before the meeting, I hesitated to really reach out to the development team in IPFS. I kind of, as I went through this for, over the last 2 months, I figured, well, when I get to a point where I'm just like so blocked, that's when I'll, kind of reach out and say, hey. But the thing is, they've made available so much good information that you can really make a lot of progress on your own if you just look a little more closely. But I did eventually, I just wrote to Juan Benet just within the past 24 hours and said, hey, to get a little bit of the bigger picture. And he was kind enough to write back. And so, at some point, but things like versioning are, those hopefully are on somebody's list for the future. And that was basically the question I asked, which is kind of
I
what's
was actually referring. I actually referred earlier to bidirectional links. Now, versioning is just a one small special case of bidirectional links.
right.
I mean, this concept is very useful. It's really a shame that the World Wide Web doesn't have this. Granted, it's kind of hard to implement, but
Yeah.
if it can be implemented, it would be very useful.
Well,
Then if you publish any document, like people might want to comment on it, and they do that by linking to it. And when links to bidirectional, that means that anyone looking at that document can look to see who's linked to it, who's commented on it.
Gotcha.
It doesn't depend on the author providing that functionality. It's just built into the system.
Gotcha. Well, one of the things that I believe does support, even in its current incarnation, is you can find out at least where these documents reside out there on the swarm of devices. One of the bit that I've had with the web, it's always been, I don't know if this bugs anybody else, but when you look at documents, you really cannot tell when the document was created, when it was revised, or by whom, right? And unless you're looking at like a Wikipedia, kind of history trail, right? But it's not self-documenting in the nature, in this idea of versioning or history. It's totally absent. So, and it would be wonderful if you could search the web based on recency or time frames or things such as that. We talked a little bit about this. These are just some acronyms, network address translators, NAT, STUN, simple traversal. These are all RFC specifications that are out there, and it's kind of complicated stuff, but it's complicated stuff that was created in order to essentially work with other complicated stuff, NAT, that was introduced to address essentially the limitation in IP addresses. And I mean, in some sense, if the web were to move to a content addressable, design or architecture, the need for a proliferation of IP addresses, it certainly is, I think, somewhat mitigated, although arguably maybe it's exacerbated because now everybody is essentially their own, every device is BitTorrent. We're not going to talk about that. You can read these.
Well, it's not like we have a shortage of IP addresses with IPv6.
Right, which is, it's true. Hash, we won't go there. References, what else we got?
I actually ran the numbers on that about 10 years ago. And I figured according to my calculation, if you assume that every galaxy in the universe has like 100 billion stars and every one of those has a planet, the full IPv6 address would be, and every planet had a population of like 7 billion people. Every person would have I think it was like a 1 million IP address subnet for every cell in their bodies. So it's like really a huge.
So here, I don't know if this will work or not, but so I've got two screens up. The screen on the left here is what the daemon looks like when it starts up, and it gives you different information. Essentially, what happens is this is, it's running the software on this local machine. The unique identifier for this device is that crazy, funky, long. I think it's 160 bits, but identifier, and that's kind of the unique identifier of this device. And you need that for a bunch of different things as time goes on. This essentially is just running, some server software on this local machine. Okay, and then on the right screen here, this is just IPFS get, and then that long 160-bit. We'll see if it's out there. It was out there at one point in time. Okay, so I just pulled that down, okay, and it saved it, and we'll just see what the so these are a bunch of different files that have been saved, and as you can see here, what it does is it's saving them to the 160-bit name that I'd rather have it saved to my PDF, right? So I'd rather have it do some kind of unwrap of the hashed content and reveal kind of what's inside. But if you were to go in and I don't know, I think most of these are text files. We'll see if we can get anything that is. I'm definitely not going to type the whole thing out. Oh, actually, so this is useful only because, so this is one of the encrypted files. So this is a good example, right? Which is, this is one of the encrypted files that I created, and I haven't decrypted it yet, and so it's kind of like, you know, it would be nice to know before you go and try and read it that the thing is, but basically that's, you know, and this is how you get files, and then if you wanted to, let's see if we, well, that's the GPG stuff. We'll just do a, and I think it's just IPFS put, and then, IPFS put, no, what is it? Well, I'll get the command right before we go. Questions? Let me put it out to questions.
So, do you know the specifics on garbage collection? Like if I create something, do I have to pin it, or is it going to disappear?
I think it's 4 days, which is the number that sticks in mind. So by default, you know, you don't have to pin it. And on the other hand, I don't know if you can say, look, I want to just leave it out there for a day or 3 minutes. Or I presume you can. All that stuff is configurable. Flip side of it is it's all decentralized, right? So that's the problem.
But if you publish high-def text, are you going to come back in 4 days and it's not even on your machine?
Oh.
Because that's not good.
You know,
that would have to be permanent, I would hope.
Yeah, that's a good question. I'm not sure. I'm not sure, to be honest with you.
Yeah.
Yeah. But it is configurable. So I think the stuff around, again, given that this is pretty early, given that nobody in the room, you know, as cozy and friendly a group as this is, had heard of IPFS before this meeting, right?
Yeah.
The fact that...
Well, I heard about it when you sent the email suggesting the meeting.
Right, yeah. So the fact that none of us had heard about this, you know, prior to 2 months ago, is, and this is early in the life cycle of adoption. That's a good question. I'm sorry, I don't know, but it does do garbage collection. Another question I have in my own mind is, okay, so you know, once you set this thing free out in the wild, I mean, you might want it to only stick around for, you know, 3 days as the default, but if that's a configuration that can be overridden, you know, out in the wild, you know, it's gone. So the other question about you know, maintaining, storing it, managing it locally, as I pointed out, these files are, you know, there's no dual kind of, here's the hash name and here's the, you know, there's no concept of the Finder. Remember the Finder in you know, the Apple Macintosh, which was like a tremendous revolution when it first came along, and it was nothing more than just essentially file listings, you know, or so those utilities just have not developed. You know, the Windows equivalent for IPFS, which is your user interface into this world, just doesn't exist. But
well, have you seen any hashes you don't recognize on any of your boxes?
oh yeah, no, and the reason is because if you're only sharing stuff with yourself, which is, well, I kind of take that back. So when you do the installation, so you did the installation, I don't know if you noticed, but
No, so I went through it and I got that cat.jpg. That's what kind of blew my mind. It's
yeah.
It was like it was right there.
Yeah.
I know it was somewhere on the other side of the world.
Well, so what they did is when you did the installation, they pre-populated some stuff in there. So
it was right there.
Yeah, it does make you feel like you're connected to somebody out there,
All right.
you know, who shares an interest in cats. But they pre-populated. One of the things I showed the directory, you know, structure, and there's like, you know, databases or documents or files or something like that. And they've preloaded a certain number of things in there. So the only way you would start picking up, and I should, let me see if I can find, I think I'll, So these are the devices that are just, in the local swarm. These are the devices which, and I'll be honest with you, I don't know how to read all this stuff, but these are other devices that are kind of out there, within reach somewhere, right? And they do tend to give you, like IP addresses that are at least look somewhat unfamiliar to me.
Yeah.
So
The local host addresses are both these are recognizable.
Yeah, local
And the
hosts,
172, that's 17 and 18, those are both on the RFC 1918 networks.
yeah,
Oh, yeah, but there's
the 39.
yeah, I got
103,
tons of IP addresses myself, but
Yeah.
you're saying you haven't seen a demo yet that actually demonstrates exactly what the functionality of IPFS is for. So I got cat.jpg off of my own machine, so that didn't prove anything to me.
No. So for me, the extent that I've pushed it to the, I had a machine in one state and another machine in another state that are both my machines, and I was able to move stuff back and forth
Okay.
without going through, example.com. So and going through different, I mean, who knows? I'd love to do a traceroute on, on that, but there's no concept of a traceroute utility that I've found yet on and I'd love to have that. So for me, the use case is exactly that model, which is devices in different locations talking to each other through some, prescribed mechanism, wherein you would have to. There's a whole bunch of other stuff that has to be developed for sure around the edges in terms of the document retention, the whole who gets access to it. Who's sharing stuff, but in terms of other people's cats showing up on your machines, it only kind of starts to happen, and I haven't. I mean, it may be happening at mine because I've certainly pulled stuff off of just like specs or things like that. That they say click here, and you can download the document off of like the IPFS network out there, and that should trigger, okay, now you're on the network, and now you're open for business, and now you're going to receive, but somebody was asking the question about, like legal files, and they actually talked about having the, sort of a DMA filter on things so that you didn't become a routing node for, the latest movie out of Hollywood. So I don't know if that answers your question or not, but the cat might have just been, it might have come with the package, because I had the same cat.
Yeah.
yeah, so, I mean, I just found the above things. So let's say if we look at that listing there with the second listing there that has a parentheses 5, which means it's in 5 different locations. That's actually not, because some of the IP addresses refer to your local machine.
And Jerry, that's a good point. I assume that's the case too, that there are sort of 5 instances of that thing around, but I don't know how to track them down at this point.
Well, you can just drop it into so IPFS.io has a Rosetta Stone for all of those addresses. So you drop that, you copy and paste that URI into your browser, and it'll open it up. But like you say, we don't know what it is. That there needs to be a proper Rosetta Stone for.
But I'm assuming, just looking at some of that stuff that you've been doing, if you once you start up the daemon, it broadcasts out. And so a couple of those IP addresses are showing essentially the port that they're on, which would not be a standard port, which means it's coming from them.
So I don't see, I understand why people run BitTorrent at their house, because the more bandwidth you give, the more bandwidth you get. But this appears to be an evangelism play right here. What's in it for me? So.
Well, in terms of, yeah, so the BitTorrent thing it's definitely a bandwidth play, for sure, right? I mean, it's also, you know, kind of off the radar play as well, potentially. I mean, certainly Linux distributions, you know, they're big, they're heavy, there's
yeah, but what I'm saying is there's no financial incentive for me to go out and set up, I guess, an IPFS server farm, unless there's some money in Filecoin. But I can definitely see why people share out their BitTorrent boxes at home. There's a direct benefit if they're a BitTorrent user. There's a direct benefit to being a BitTorrent giver.
right.
I'm not seeing that equation here.
Yeah, I don't think that, and maybe that's what has spurred them on to look at the Filecoin, you know, mechanism for storage. So, I mean, you potentially could, like in my application, to a large extent, it's kind of self-contained and, you know, self-managing, and it doesn't rely as much on the existence of other nodes out there. It's just, it relies on the distributed nature of it, but you know, it's more of a self-sufficient thing. Let me just do a couple more commands if anybody else has any other questions. The repo stat, so this just, you know, it talks about some really basic stuff. It tells you where the path is located. Let's see what the config show. Config. You know, so actually, I wouldn't be surprised if, you know, like that 12-hour thing is, you know, there's some configuration thing in here that gets to the nature of some of the stuff that you were asking about earlier. The bootstrap list, let's look at that. IPFS. Bootstrap. So this does, and I don't know if anybody's handy with IP addresses, but I kind of looked at this and I just wondered, are those 104s? Are these, so these are systems that I think come up at, you know, at boot time. And are these systems IPFS systems or what? I'm not really sure. But this would be, and there's some IP6 in there as well. So this presumably is the place you go to pre-configure your system. The question about pinning. So this shows the documents which have, you know, been pinned, and I think some of these are the ones that came pre-configured, pre-installed. I don't actually know what indirect versus recursive is, but it's, you know, it's some attribute that. So you can ping. It does have a ping command just to see if something's out there that is of interest to you. And oh, here's the. So let's see. The swarm peers. IPFS. Swarm peers. So these are the machines that you know, my machine thinks it somehow is connected to. Can people make 210, 213? Do any of those numbers make any sense to?
Yeah.
What are they?
They're external
217
IP addresses.
So these are, for whatever reason, these IP addresses are, you know, they're running an IPFS node, and I'm guessing that, I mean, I hesitate to, you know, get the files because we don't know what's going to be on the other side of them, I suppose, and they could be more than just cats. But But presumably those are,
So you said earlier you have no way of determining what a file is without looking at it?
That's, yeah. I haven't seen anything that, so that whole, I mean, it's the whole like echo system of, of essentially defining this universe of information that all they've built, what they have built so far, which to me is completely remarkable. It's almost like they've built the architecture for storing the world's knowledge in a library, but they haven't really completely finished the cataloging system yet. So it's got the superstructure of where you're going to put all this stuff, but in terms of actually how you how you label it and how you see what's there, that's all a bit of a mystery at this point in time. So, which to me isn't too terribly discouraging, because I sort of see this as fairly young in the life of the system. Let's just see what this is here. Oh yeah, so this is this tells you a little bit about, again, they've given basic system utilities which are useful for doing debugging kinds of things. And then we kind of, we've seen, sometimes a few of these things appear in different ways, but this is the configuration. So 1811, 111, 63, 140 is, so that's the addresses that it's.
Yeah, that's your IP address.
Yeah, that's, so it kind of creates that dynamically, which is, I guess, what you'd expect.
Yeah, and that's the address you get from MIT.
Yeah.
The 127.0.0.1 is your local host, of course.
Yeah. And
as is the : (1) for IPv6.
And the thing that ends in the PH up there, so that's the unique identifier that goes with this machine, with this installation of the daemon. And if you wiped it out and initialized it again, you would get a new unique identifier. So,
What's the overhead with the daemon? You can just type in top or something so you can see what it's probably not that bad. Yeah, so it's, well.
Yeah, it's pretty up there.
Yeah.
well, I mean, I'd expect that it's busy, but then it backs off when you're doing other stuff. I know, that's a good question though. I have had this actually running on a Raspberry Pi fine, and I just started using laptops instead because it was a little easier to carry around. But it installed fine and ran fine on our Pi. And so that would be, to me, that's the model that you've got. You've got some kind of cost-effective small device that's just running all the time. And it becomes your communications hub for your IoT devices, your refrigerator, your dishwasher, whatever it is that you got talking to these things. And what else? Any questions? So yeah, sure. Go ahead.
What's the delay when you introduce like a new document for it to propagate?
So it's virtually instantaneous. I mean, again, I haven't done a whole lot. I'd love to. I mean, if people are interested, we could easily get a tiny network of you come up with some kind of a clever application that to test some of this stuff. But the propagation delay for doing essentially the file hashing, it's just it's quick. It's like saving a file basically, and then for actually putting it out there, I mean, from what I've seen, it's certainly instantaneous. But the thing that does take time, and I don't know why, is when you go through this IPNS process, the IP naming service process, which is to kind of create this essentially more dynamic and lasting and adaptable name. For some reason, that just it takes too long. It takes seconds instead of just instantaneous. So now if you're hashing a 30 gigabyte file, then I have not tested that yet. Most of the stuff I'm working with is just really small files. So, but the process is the same, which is it chews through. I think it chunks the same way BitTorrent would do large files. It goes through that. So it's not really doing this the way it's set up in real time. It's more of a batch process. You chunk it, you pre-process it, and then you push it out. And you have a new file, you chunk it, you pre-process it, and you share it. You get the same experience if you're trying to upload a large PowerPoint file to it's a different kind of chunking that's taking place. But from the standpoint of just retrieving stuff, it doesn't seem to hiccup. It would be great, and that's kind of a good suggestion, along with the performance monitoring. How do you measure when people do start sharing files or sharing chunks or hitting your machine? What kind of interruption is that on, at some point, presumably some, but at least my model is it's a dedicated machine that you just let run, unto itself. Does that somewhat answer? Any other, Bill, any sort of security hacks that you just, you're appalled at the thought that they're...
Well, the basic problem security-wise with hash detection and duplication when you address files and file chunks by their hash is it's then trivial to find out which chunks are containing given content. If you want to share a message from the leader of a subversive group, unless you edit each version of the video to be slightly different in length or have a couple of pixels changed to throw the hash off, all copies of it are going to have the identical hash for the object.
Right.
So once the sensors find one copy, they instantly know the name of all of them.
Yeah, that's a good point. I would theorize that if stuff were encrypted, then every copy, even though for instance it's the same PDF.
If you salt the encryption, that would defeat that, but then you're then you're giving up the basic structure of the content addressability, and if you don't salt it, then you've hidden what it is, but still, once you find one copy, you know the name of all copies.
Not if it's encrypted, because every encrypted copy would be different, right?
If you salt the encryption, yes,
Yeah.
and then you would step aside
Yeah.
from the basic tenet of content addressability.
Well, you'd still
So
have
your content addressability and protection from the governmental suppressive function are in tension with each other. You can't have both.
And you do, anytime you start encrypting stuff, then you lose whatever the deduplication is. Or
Exactly.
Yeah. So you certainly do start to, you need to.
There's a choice that has to be made there.
Yeah, that's a good point. That's a good point. I do think, I don't know if other people see it this way, but it seems to me that, as soon as the first thing you do as you step into the world of a decentralized web, I think is you bring on more encryption as essentially a necessary, prudent first step in sharing anything other than completely public, public service announcements, basically. Also, given that once you share it in this distributed way, you lose control. Or, I mean, on the one hand, the Geocities problem, it really is a problem that, you know, if your stuff is out there and somebody else makes the decision to do away with it, and you were kind of relying on them to be the historical arbiters of it, that's kind of a bummer. Flip side of it is, if you put your stuff out there in the other extreme, which is the, you know, the public domain, you kind of lose the right to be forgotten. So in some sense, it runs counter to the stuff that's going on in Europe right now. Or is it not IPRS or IDRS?
But since it's not centralized, there's no individual that's violating.
Yeah, so I don't know if you've thought about that, but I do wonder how that plays, because you know, if people put their own stuff out there, then who are they signing the contract with for you know, for use and distribution? It's when you hit the send button, it's you that's putting out to the public eye. So I think there are a lot of, you know, those are more kind of policy or political or usage questions. There are a lot of big questions. There are a lot of technical questions. There are a lot of utility questions about, you know, how do you string all this stuff together? And so, but it is really young in the, I mean, I don't know where, if you look back to when the first web browser was at 95 or thereabouts, that you know, that it came out, and I mean, how long before you had a good 5 or 6 year stretch before things really, at the turn of the millennium, took off. So, well, hey, thank you. If there are, you know, any other questions, if not, I hope that 3 years from now we can be talking about this stuff and it is the hot sauce of the day. But if not, it was just another wasted Wednesday night in Cambridge. So thank you for coming. We'll do it again sometime.
Okay, thank you, Brian.
So,
Just want to mention the BLU barbecue, which will be a week from Saturday.
also, our annual
John
key
Chambers?
signing is next month.
What?
Our annual key signing meeting is on September 19th.
Yep.
Yep.
I probably won't be here because I have a cataract surgery that day.
So I wonder if you could, with the key signing, could you add in something along these lines? Because basically, as soon as you have, I mean, do people actually use the keys that they sign? And if so, for what?
I use my key, I don't use it with my Gmail, but I use it, you'll see when I send out a message from gaf@blu.org.
Yeah.
My messages are all signed.
And so that just so that we know
And
that it's you.
I can sign them from my Gmail because I have that add-on that has my key.
And if you're uploading commits to GitHub, you should use a GPG key
Yep.
to indicate that it was really you and not somebody forging your identity.
So that's more, so it's authentication as opposed to, you know.
Well, I use it
It works both ways.
both ways.
Yeah.
When you authenticate, what you're doing is you are using your private key to encrypt the hash, and then when the reader uses your public key to decrypt it to verify the sign. When you encrypt,